data tables today. Data tables are an essential element to doing an experiment. Because if you don't have a data table to collect your data, you're going to have just a pile of numbers on your paper, and it won't mean anything to you. You won't be able to figure out what your experiment is trying to tell you. So on your Cornell notes, you're starting off, what is a data table? The answer to that question is it's a tool for recording, organizing, and communicating data collected during an experiment. There we go. It is a tool for recording, organizing, and communicating data collected during an experiment. And like I said, it's essential. If you don't have a data table ready to go before you do an experiment, you are liable to make mistakes in collecting your data, and your data will not mean anything to you. Okay, first rules. Rule number 1, always number and title your data table. It's, like I said, literally, you're numbering it. Table number 1. The reason you do that is quite often in big experiments, you're going to have more than one data table. So when you're talking about your conclusion, then you can refer back to the data tables in your conclusion. In table number 1, you can see blah, blah, blah. When you look at table number 3, you'll be able to see blah, blah, blah. So you're able to refer to them, and then the person reading your experiment would know what data table you're talking about. The next thing your data table needs is not only to be numbered, but also to get a title. And the example that I'm giving you, we're going to say the amount of salt dissolved at different water temperatures. Anybody know why I changed pen color halfway through that title? I see a few hands go up. Natalie? Very good. I just did, you don't have to do this. I just did it because I wanted to make sure you realize when you are making a title, whether it's for a data table or a graph, you always need to have the independent variable, which I put in blue, and the dependent variable, which is what I put in red. Okay? So your title of your data table should have the independent and dependent variable included. Okay? So that's item number 1. So you've numbered it, you've given it a good title. Now item number 2. You need to separate your data table into columns and rows according to the amount of data that you've collected. It's very logical in that on the left-hand side, that's going to be the independent variable. And on the right-hand side, it's going to be the dependent variable. I say that is logical because it's the cause and then the effect. The cause and then the effect. Independent variable goes on the left-hand side, The dependent variable goes on the right. And item number 3, always put units and labels in the column headings. So each one of these columns go up and down, remember. You need to tell me what those numbers mean. What are they representing? So the first one is water temperature. And that is measured in degrees Celsius. You're giving me 2 things, the label and the units. On the right-hand column, the dependent variable, that is the amount of dissolved salt. So that is going to be measured in grams. So again, 2 things, the label, and 2, the units, how it is measured. And now your data table is done and ready to go, okay? You've got it numbered, you've got it labeled with a good title, and then your data, the column headings are given a label and the units that they were measured in, and you're ready to go. But one more thing, let's talk about one more thing. I'll wait one more minute here. What's the purpose of multiple trials and increasing the sample size? Why is it important to do an experiment more than one time? Why would that be, Josie? Yeah, to eliminate any mistakes or factors that aren't supposed to happen. If you only do an experiment one time, maybe something was wackadoo in that experiment, and you don't necessarily realize that. By doing the same experiment multiple times, you are going to collect data to let you know, did I screw that up, or is that right? If your data is pretty close to one another, then you're like, oh yeah, that's correct. The more and more data you have, the more reliable your results are. The more reliable your results are. Can somebody tell me what reliable means? If you are a reliable person, what am I saying about you? You're honest. What else does reliable mean? Trustworthy. That's what I really like, that word, trustworthy. If you do multiple trials or have a larger sample size, if you're taking some kind of a survey, the more data you have, the more reliable or trustworthy your data it will be. It is more believable than if you only do an experiment one time. Those results might be just a fluke. If you do the same experiment 1,000 times and you get the same results almost each time, then you know for sure those results are very reliable. Okay? Let's take a look at your homework, which is due on Friday. You guys are going to be making a graph. This first investigation, it says a seed was planted. As the plant grew, it was measured over a 6-day period. Day 1, it was 0 centimeters. Day 2, it was 2 centimeters. Day 3, it was 5 centimeters. so on and so forth. Okay? So if you're doing this experiment, what are we measuring? What are we observing? What are we measuring in this experiment? Claire? Yeah, what about this? How it grows. Very good. We're measuring the height of the plant. So that is the dependent variable. So I'm going to put on this side plant growth, and that is going to be measured in centimeters. What's the independent variable? What's causing the differences? Plant growth is the effect. What is the cause? April? The days. Very good. So the independent variable is the time, and that is measured in days. So this is data table number 1, and I'm going to call this plant growth over 6 days. And now here comes the hard part. I've given you guys rulers at your seats, and I fully expect you to use them. You want to take the space that you have and equally divide it so that your rows are going to be about the same size. I think we've got 6 days, so I'm just eyeballing it. You guys can, my computer's freaking out now. 1, 2, 3, 4, 5, 6, 7. And you guys are not doing what I'm doing. I don't want willy-nilly lines. I want nice straight lines that are as evenly spaced as you can make them. Don't do willy-nilly. I'll be grumpy if I see willy-nilly. And then after you get your lines made, you're going to place your data. So this is day 1, 2, 3, 4, 5, 6. Day 1, it was 0 centimeters. Day 2, it was 2 centimeters. Day 3, it was 5 centimeters. Day 4, it was 7 centimeters. Uh-oh. Here's just about done. 7 centimeters. Day 5, it was 8. And day 6, it was 10. Okay? So you guys are going to do a neat version of what I just did. And then there are 3 other data tables that you are going to do. Should you use a pen? Probably not. I would definitely use a pencil when I'm doing this activity. Using a pen can be catastrophic because you can make lots of mistakes using a pen.